Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. Hello everyone, I hope you're all doing well. Welcome to another video from your channel, YouTube channel Easy Chemistry for All. This is Mr. Muad, and before we continue, please share and subscribe to the channel if you hadn't done so, and share it with your friends so that many more students can hopefully benefit bi'idhnillah. Also put a like, guys, in the video so that it can be accessed by many more students. Thank you. So we are still in the chapter of the mole, okay, and we are going to start in lesson 4, empirical and molecular formula, الصيغة الجزيئية والصيغة التجريبية. Okay. So by the end of this lesson, you should be able to explain what is meant by the percent composition of a compound. يعني الجزء الأول راح يتكلم على percent composition of a compound، يعني نسبة التكوين حق المركب. And then determine the empirical and molecular formulas for a compound from the mass percent and actual mass. يعني نحن نقدر كيف نطلع الصيغة الكيميائية حق المركب من نسبة التكوين اللي هي percent composition, which we are going to see. Okay, so this video has 3 sections, and we are going to start with part 1, which talks about percent composition, inshallah.
So, Bismillah ar-Rahman ar-Rahim. Hello everyone. So we are going to record 3 videos for lesson 4, okay, which is empirical and molecular formulas. This is module 9, okay, or chapter 7, 1, 2, 3, 4, 5. We're on chapter 6, yeah, chapter 6 or module 9, okay, in your Inspire Chemistry book. So let's begin. So in this first part, we are going to learn the following. We will find the percent composition of a compound from experimental data and chemical formula. What does percent composition mean? We are going to look at that in the next slide. Okay, so we are going to explain what's the meaning of percent composition of a compound, and we will learn how to calculate the percent composition of a compound from experimental data من البيانات and from the chemical formula. Okay, so we need to learn the keywords here. So the first keyword is the percent by mass. It's the ratio of the mass of each element to the total mass of the compound. So percent by mass of element X, for example, will be the mass of element X over the mass of the compound times 100. So it's like a percent equation in math. Now the percent composition is the percent by mass, this equation, for every element in a compound. What does that mean? If I have a compound AB, okay, if I found the percent by mass of A and the percent by mass of B, this thing here is called the percent composition of AB. نسبة تكوين مركب AB، كم نسبة ال A منه وكم نسبة ال B منه بالكتلة، الماس. Okay, and how do we find the percent by mass? By this equation, super easy. Now before we go through the percent by mass and percent composition, you can stop the video after reading this question and trying to find the molar mass of CO2. So this is a revision of lesson 3. Okay, yeah, so we know the molar mass of oxygen, of carbon. How many C's do we have? We have 1, so 1 times 12 molar mass of carbon. How many oxygens do we have? We have 2, so 2 times 16, which is the molar mass of oxygen. We add both answers, we get the molar mass of CO2. Okay, so remember that. Now, the percent composition can be found from this equation. Okay, for every element, if I have XY, I need to find the percent by mass for X and the percent by mass for Y. Okay, and that's how we find the percent composition. Now we are going to find it from experimental data. They will give us the masses of elements in the compound. Okay, So the masses of elements in the compound will be given. For example, if you have a compound, so compound, okay, 55 grams is X and 45 grams is Y. So what's the percent composition? What is the percent composition of the compound? So you just use this equation. First we'll find percent by mass of X. It will be the mass of the element, which is the mass of X here, 55 grams, over the mass of the compound. So the mass of the compound is going to be the mass of X plus the mass of Y, لأن المركب بتكون من X و Y. So it will be 55 grams plus 45 grams. So it will be times 100, of course, don't forget that. So it will give us 55%. Now the percent by mass of Y will be 45 over 55 plus 45 times 100. It will be 45%. So this is the percent composition of the compound. 55% of it is X, 45% of it is Y. And you need to remember, when you add the percentages, they should be or give you 100%. The total should always be 100%. If it's not 100%, it means you have a mistake. So what's the percent composition of carbon C and hydrogen H in a compound? هم في مركب. If you know that the mass of carbon is 20 grams and the mass of hydrogen is 5 grams, so you know you need to find the percent by mass for carbon and for hydrogen, and you need to find the total mass of the compound. So the mass of the compound, which is this one, is going to be 20 اللي هي الماس of carbon plus 5 الماss of hydrogen, so it will be 25 grams. So the percent of carbon will be 20 divided by 25 times 100, so it will be 80%, and the percentage of H is going to be 5 over 25 times 100, which will be 20%. Okay, and that's exactly how we do it. All right, so this is the percent composition from experimental data. Okay, this is from experimental data. يعطونا المasses. The masses are given. They give you the mass. Okay, now pick your understanding. Is this equation correct or wrong? The percent by mass equals mass of compound over mass of element times 100. So the answer here is wrong. We should switch this one with this one, right? It's mass of element over mass of compound times 100. So this is wrong. Now, which one is the correct percent composition for carbon monoxide? So carbon monoxide is the compound CO. Carbon حبة واحدة, monoxide, mono, remember mono is 1 and oxide is O. So which one of the following is going to give you a correct percent composition? Well done. The correct answer is C. Why? Because when you add 45 plus 60, it will be 105%. If you add 43 plus 57, it will be 100%. If you add 50 plus 52, it will give you 102%. So the sum should always be 100%. This one is wrong, and this one is wrong. And our correct answer is number 2. Alright, so that was the first part. I mean, not the first part, I mean the first section of part 1. Now we will learn about the percent composition, same equation, but not from experimental data. We will not have grams. We will get it from the chemical formula. So the first step, so step 1, find the molar mass of the compound. For example, CaCO3. طبعا finding the molar mass, we already saw it in lesson 3, molar mass of compounds. Okay, so we already studied that. So that part should be easy for you now, because you have the molar masses of calcium, of carbon, and of oxygen. Okay, so how do we do it? There's a quick way and a lengthy way. So the quick way is to see how many CAs do we have. We have 1, so 1 times 40.078 plus كم C عندنا؟ 1 times 12.01 plus how many oxygens do we have? 3 times 15.999, and you get your answer. That's it. Okay, and we can do it this way. نحسب هاي بروحها وهاي بروحها وهاي بروحها. Okay, which is what I want you to do when you find percent composition from chemical formula, and I'll show you why. You find the percent of carbon, see 1 times 12, 1 times 40, and then 3 times 15.99. Then you add, right? So your answer will be 100.085 gram per mole. هذه المولر masses. Okay, now the equation for the percent composition from the chemical formula, احنا عندنا هنا ما عندنا grams أبدا, is the following. So the percent by mass will be the mass of the element in 1 mole of the compound, اللي هي هاي القيم اللي نطلعها هنا. Okay, over the molar mass of the compound which we found here. Okay, so what is the percent by mass for calcium? It will be this mass over the molar mass, 40% times 100. نفس المعادلة لكن اختلاف في الأسماء. Now what's the percent by mass for carbon? It's 12.01 divided by 100.085. Okay, times 100 gives us 12%. Now the percent by mass for oxygen, it's not 15.99 divided by the molar mass. No, it's the mass you have in the formula, لأنه عندنا 3 حبات أكسجين فلازم نضرب الثلاثة في المولر mass. You get it? You divide by the molar mass times 100, you get your percent. So this is the percent composition. Sorry, this is the percent composition from the chemical formula. الأمثلة السابقة, the previous examples, you have the mass, so you use it directly. Now you don't have the mass, you have only the formula, the chemical formula. Okay, الصيغة الكيميائية. And this is how you do it. Okay, that's it. So all of this is the percent. أنا كلمة percent أكتبها كنسبة لأنه هاي النسبة معناها percent. So percent composition of CaCO3. Okay, now you can have more practice on this. So they give you here a compound, calcium chloride, CaCl2. Calculate the percent by mass of each element. Okay, CaCl2. So as you know, step 1, find the molar mass of CaCl2. So first let's find mass of Ca. So it will be, how many Cas do we have here? 1, right? So 1 times 40.1, so it will be 40.1 grams. What's the mass of Cl? It will be 2 times, ليش 2? Because we have 2 Cl's here, times 35.45, so it will be 70.9 grams. Now the molar mass equals 40.01 plus, sorry, 40.01 1 not 0 1 40.1 plus 70.9, which is actually 7.9 plus 40.1, just to make sure it's 111. Yeah, 111 gram per mole. Now use this equation. Just use this equation. So the percent by mass of Ca will be this number from here. لما نيجي نحسب المولر mass, we need to take the mass in 1 mole of the compound. لأن هاي الفورمولا, this formula means 1 mole of CaCl2. لأن it's only 1, okay? So it will be 40.1 divided by 111 times 100, which is equal to 40.1 divided by times 100. It will give you around 36% تقريبا, okay? And the percent of Cl, it will be 70.9, مش 35 من هني, 70.9. Why? Because I have 2 Cl over times 100, so it will be تقريبا 64%. And that's it. Finished. If you know how to do this, we finished the first part, okay? So you can have more practice here if you want, and yeah. Also, you can have more practice here if you want. You can find the solutions in on LMS. And yeah, we learned how to calculate the percent composition of a compound and the percent composition, and explained what's the percent composition of a compound. Okay. So hello everyone, welcome back to part 2 from lesson 4 of module 9, which is chapter 6, and we are learning about the we are learning about the empirical and molecular formulas, okay? And these are the book pages. So our main goal in this part is to find the empirical formula from the percent composition. Okay, so remember in the previous part I give you the chemical formula, right? And then you find the percent composition, right? In this class, in this lesson or video, I'm going to give you the percent composition, okay? And then you need to find the empirical formula, okay? Don't worry, we will see what do we mean by the empirical formula shortly, okay? But it's a type of a chemical formula, okay? We are going to see that shortly. So we will define something called empirical formula and molecular formula. All right, we'll see what's the difference between both. So molecular formula is الصيغة الجزيئية or the real formula. Empirical formula is the experimental formula, okay? And we will learn the steps and how to find the empirical formula of a compound from the percent composition, okay? So we're talking about compounds here. Now, what do we mean by the empirical formula? So the empirical formula is the chemical formula for a compound that has the smallest whole number. شو معنى whole number؟ whole number معناه 1 2 3 4 4 5 6. Okay, no decimals, ما في فواصل. Okay, the whole number mole ratio of the elements. For example, if I have a compound CH4 What's the ratio between C and H؟ كم C عندنا؟ حبة واحدة صح؟ والH حبة واحدة. So it's 1 to 4. هل هذه is this the lowest whole number ratio? Can I divide? Is there a common factor here? No. But if I write C2 H2 H4, sorry, the ratio here is 2 to 4, right? Is there a common factor? Yes, it's 2. So we divide by 2, divide by 2. Now we get 1 to 2. So CH2. Now this one is the lowest ratio. So this is the empirical formula. This one here is not the empirical formula. Okay? يعني أقل نسبة ما بين العناصر تكون في المركب. هاي الصيغة الكيميائية نسميها الامبيريكال formula. Now the molecular formula is a chemical formula بس فيها the actual number of atoms of each element in one molecule or a formula unit. What does that mean? For example, في الطبيعة water is H2O, right? The percentage here or the ratio, mode ratio between H and O is 2 to 1, right? Because you have 2H and 1O. Now this is the actual thing. لأن في الطبيعة المية is H2O. It's also the empirical formula. Okay? So the molecular formula can be the empirical formula and sometimes it's not. Okay? But it's the actual number of atoms يعني العدد الحقيقي للذرات اللي موجودة في الطبيعة. المركب كيف موجود في الطبيعة. So now we can go through this example quickly. Going through the mole ratio, okay, the mole ratio between oxygen and hydrogen, so O and H in each of these compounds. So the ratio here is going to be 2 to 1. So here H نسبة ال H إلى الأكسجين. Here it will be 2 to 2 يعني 1 to 1. Here it will be 1 to 3 because we have 1 H and 3 about, okay? So now I'm going to give you the molecular formula and I want you to find the empirical formula, okay? So CO2, what's the empirical formula? Excellent. It's going to be CO2. ليش؟ لأن النسبة هنا 1 إلى 2 1 to 2 ما في عامل مشترك. H2O 2 to 1 same أقل شيء ما في عامل مشترك. Now N2O4 2 to 4 في عامل مشترك أيوة الاثنين. نقسم على 2 هني نقسم على 2 so it will give us N1O2. okay ما نكتب الواحد في الكيمياء. P4O10 there is a common factor which is 2, so if you divide by 2 it will give you P2O5 C10H22. if you divide by 2 and divide by 2 it will give you the empirical formula. Now C6H18O3, if you divide everything by 3 you will get C2H6O. طبعا you might think that 2 and 6 they have a common factor. No, the common factor should be for every element here. The ratio is 2 to 6 hydrogen to 1 oxygen. ما في بينهم كلهم عامل مشترك. So that's our empirical formula. This is the lowest or simplest whole number ratio. Okay? So yeah, if you know this, then you are good. You know the difference between empirical and molecular formula. So in other words, the molecular formula can be a multiple of the empirical. شو معنى هالكلام؟ ال NO2 here, this is empirical, right? إذا ضربتها في 2 multiply 2 here and here, it will give us N2O4. This is the molecular formula. Can you see? So it can be a multiple. Okay, which one here is the empirical formula of glucose? This one or this one? So here is 6 to 12 to 6. Is this the simplest ratio? No. This is 1 to 2 to 1. Is this the simplest ratio? Yes. So this one is our empirical formula. This one is our molecular formula. You can go through this link here, which you have in the PowerPoint presentation on LMS, to learn more and more about the empirical and molecular formulas. Okay, if you want to watch some videos about it, it's very helpful as an additional resource. Okay, now remember, our main goal here is that we can find the empirical formula from the percent composition. الدرس اللي فات الفيديو اللي فات كنت أعطيكم الفورمولا وتطلعون ال percent composition. Now I'm going to give you the percent composition or the grams, the masses of the elements, and then you need to find the formula. So we have a rule here. These are the steps. You just need to follow the steps and it will all make sense. If given the percent composition, يعني يعطوكم نسبة السي مثلا الكربون، نسبة الأكسجين and so on, assume the total mass of the compound is 100 grams. Okay, so if you multiply 100 grams by the percent, it will give you the same number. So actually, the percentage that they give you is actually the mass of the element. So you just change the percent into grams directly. What does that mean? It means you need 4 steps to calculate the empirical formula. Step number 1, assume you have 100 gram of the compound and convert the percent composition to grams. مثلا إذا قال لك إنه مثلا العنصر X the percent composition is 45%, this percent just change it to grams. So this is the mass of X. Okay, good. This is the first step. Sometimes they will give you the mass على طول, sometimes they will give you the percent. Now step number 2, convert the mass into moles. Sorry, how can we do that? You know that equation of moles equals mass over the molar mass, and the molar mass will be given to you. So given يا إما في الجدول الدوري periodic table or in the question, and the mass you find it from step 1. So find the moles. Now divide by the lowest mole fraction to find the smallest whole number ratio. So in here, for example, you might have 2 elements, element A and element B. Here the moles is 0.5 mole, here the moles is 1 mole. So what you need to do, you need to divide A and B by the lowest number. Which one is smaller, 0.5 or 1? 0.5, yeah? So you divide everything by that, and then step 4, you write the empirical formula from the ratios, okay, indicated by subscripts. هاي الستep الأخيرة والstep number 3, there might be a problem in understanding them here, okay? But I would like to show you through an example. That will make more sense, okay? So don't worry now if you're confused. Let's go to an example and use these simple 4 steps. So imagine a 100 grams sample where it is 40.05% sulfur اللي هو S الكبريت and 59.95 oxygen. So this is the percent. See, they give you the percent composition. Find the empirical formula for this compound. So they give you, so given percent composition, right? The percentage of S equals 40.05. The percentage of oxygen equals 59.95. Okay? And the unknown is the empirical formula. So S, X, O, Y. We don't know these numbers. We don't know the formula, the empirical formula. Okay? So how can we find it? So step 1, remember steps, step 1. The mass equals percent. Okay? Because we have 100 grams, remember? So actually mass of S is going to be 40.05 grams. The mass of oxygen will be 59.95 جرامز. النسبة هاي نحولها لجرامز على طول. طبعا إذا رحنا للجدول الدوري, if we go to the periodic table, you'll find S32 here, and then you will find oxygen 16. So this is the molar masses, huh? These are the molar masses, gram per mole. الجدول الدوري. So step number 2, if you remember, step 2, find the moles. Okay, moles equals mass over molar mass. So moles of S equals, what's the mass of S? This one, 40.05 divided by the molar mass اللي هي 32 من الجدول الدوري. So it will give you 40.05 divided by 32. So it will give you 1.25 mole. Now what is the moles of oxygen? It will be 59.95 divided by 16. 59.95 divided by 16. So it will be equal to 3.7 تقريبا 5. الحين نيجي للخطوة الثالثة اللي هي divide by the lowest mole fraction to find the smallest whole number ratio. So do you see this X and Y? Okay, so these are the subscripts. Okay, اللي بنحطهم. Now X is for S and Y is for O. الحين step number 3, we need to divide the moles that we found by the lowest value. مين أصغر 1.25 ولا 3.75? Of course this one. So we are going to divide, so for S we are going to divide 1.25 by 1.25 نفسها. So it will give us 1. Now this thing here is actually the X. This is the X اللي هي موجودة هنا. Okay, and we will, for oxygen we are going to divide 3.75 تقسيم, sorry here I don't know what's happening but it's not allowing me to write down here. Now for oxygen it will be 3.75 divided by 1.25, so the answer will be 3, and this is actually the Y. Now what we did here is we found the mole ratio, so the mole ratio between S and O is 1 to 3. معناها كل حبة S عندي في المركب يقابلها 3 حبات من O. So the empirical formula is SO3. okay, لأنه S واحدة ما نكتب واحد والأو منها 3, and that's it. So this one here is actually step number 4. Use the mole ratio that you find from here, step 3, to write the empirical formula. Okay, so these are the steps, and this is what we have done in here. So I solved it. So this is what we have done here. We find again these percentages, we convert them to grams على طول, and then basically you divide this by the molar masses, you find the moles, then you divide by the smallest mole fraction اللي هي هاي. Okay, you get 1 and 3, this one for oxygen and this one for S. Okay, and then you write your formula. Okay, this is the empirical formula. Easy. You can stop the video and repeat it again, but if you know how to go through these 4 steps, It's all the same. Okay. Now it's worth mentioning. Let's get this one. Yeah. It's worth mentioning that sometimes when you divide, for example, let's say that you divide in step number 3. Let's go back. Maybe it's better to go back. So in step number 3, imagine you are trying to find ax, by. Imagine for x you divided step number 3 على أصغر رقم. For example, the example that we have here actually. Okay. The example that we have here. Okay. So we divide x is for a. Okay. So this is for a. So we divide the number of moles of a by 1 by 0.5 sorry لأن هي أصغر شيء. So 1. Now we divide for y, we divide the number of moles of y, which is 1, divided by 0.5. Okay. It will be 1 second. Now imagine okay, let me erase this one. Just give me 1 second. The mouse is not working. Erase. So imagine the number of moles you get for A is actually 3, and the number of moles you get for B is actually 2. Imagine this. So if we go for Y, it will be 2 divided by 2, which is 1. If we go for for X, it will be 3 divided by 2, which is 3 over 2. Okay, it's the same thing. So now this is your X and this is your Y. So you will write A, what's the X? 3 over 2, and B, 1. We can't write something like this in the subscripts. لازم نتخلص من الاثنين هاي. فشو نسوي؟ نضرب هاي كلها في 2. If we multiply this by 2 here and here, this one will go with this one, and 2 times 1 is 2, so you will get A3 B2. Okay, this is just an example. When you have something like this, sometimes you will have 5 over 2 or 7 over 2. لو كان عندنا كسر في الخطوة الثالثة لما يطلع كسر لازم نتخلص منه إنه نضرب المعادلة كلها في بسط هذا الكسر، الفورميلا كلها في بسط هذا الكسر. Okay. Now again you can try this on your own. This example you can try it on your own. It's in page 3 in this link. And yeah, that's it. We can start part 3 inshallah in the next video. Okay, so we are at the last part, okay, of module 9 lesson 4. In this video we are going to learn how to find the molecular formula. So remember in the previous part we learned how to find the empirical formula, right? So now we are going to learn how to find the molecular formula, not just the empirical formula. So learn how to find the molecular formula itself. Tamam? Now step 1 actually is find the empirical formula. So الجزء الأصعب أو الأطول هو finding the empirical formula, okay? Which we already know from the previous video. So that should be easy for you to understand, okay? And then step 2, okay? Divide the molar mass. We'll call this MF of the molecular formula over the molar mass of the empirical formula, okay, the E, and you will get a number N. Now step 3, multiply the EF by N. What does that mean? So from step 1, you get CH3. Imagine, right? Now from step 2, you get, when you divide the molar mass of the molecular formula by the molar mass of the empirical formula, you get N equals 2. Now in step 3, you are going to multiply 2 by CH3. الاثنين تروح عند كل عنصر تحت تضرب فيه. Okay, تضرب في الرقم اللي تحت. So you can find that the molecular formula is actually C ضرب 2 is C2, 3 ضرب 2 6, C2H6. That's it. This is the logic. These are the 3 steps that we do to find the molecular formula. Now we are going to see it through a detailed example, okay? So we already know the meaning of empirical and molecular formulas. Now, these are the steps you have in your book for finding the molecular formula. Okay. So, remember this was step 1. Express percent by mass in grams. So if they give you the percent composition, اعتبرها grams, find the mass of the elements. Step number 2, find the moles. So it's mass over the molar mass. Okay. Step number 3, remember, divide every mole from here by the lowest number you get. For example, if you have AB, compound AB, so A number of moles is 0.5 mole, B is 0.7 mole, divide by 0.5 mole. Divide A by 0.5 mole, divide B by 0.5 as well. Now, if everything is whole number, for example, if you get 2 to 3, for example, after you divide, that's it. Then your formula is A2B3, for example. If not whole numbers, then multiply by the smallest factor to that will produce whole numbers. What does this mean? Remember لما طلع لنا A3 على 2 and B? So we can't have something like this. So we need to multiply by 2 to go here and go here عشان هاي تتكنسل معها يطلع عنا A3B2. And this will be your empirical form. Okay? So if it's whole numbers, well done. If you have ratios, لما نقسم طلع لنا عدد كسري with decimals, use something like this. But if you get 2.9, you can make it 3. Okay? If you get 3.2, you can make it 3. Okay? Then divide the experimental molar mass هذه given, okay, in the question اللي هي of the molecular formula. Okay, it will be the molar mass of the molecular formula by the mass of the empirical formula. Then multiply the subscripts by n, as we saw here. Remember, this is what we saw here. We multiply this number by the empirical formula, and finally you get your molecular formula. Let's see an example. So, succinic acid, هذا acid حمض, is a substance produced by lichens. Chemical analysis indicate that it's composed of 40.68% carbon, 5.08% hydrogen, and 54.24% oxygen, and has a molar mass of 118.1. هاي هي experimental molar mass اللي قلت لكم تعطاكم في السؤال. This is the experimental molar mass given to you in the question. Okay? Because chemical analysis, تحاليل كيميائية. Determine the empirical, حلو نسوي مراجعة empirical formula and the molecular formulas of succinic acid. Of course, you can't find the molecular formula without finding the empirical first, because that's one of the steps. So, first of all, write what you know, what they gave you. Okay? They give you the percent by mass for carbon, carbon C, hydrogen H, oxygen O. They give you the percent by mass for hydrogen. They give you the percent by mass for oxygen. They give you the experimental molar mass. They want you to find the empirical formula and the molecular formula. أول شيء نبدأ بالempirical formula. Remember, 4 steps. So let's start with them. Step 1, step 2, step 3, and step 4. So step 1, you need to change these percentages into grams. Okay, على طول 0.8 grams على طول 4.24 grams. Now this is very important. When they don't give you the mass of the compound, if they give you the mass of the compound, you multiply this percent by the mass of the compound. Okay, so we already saw this in the video of part 2. You have so steps 1 and 2. So we are going to combine step 1 and 2 here. Okay, so step 1 and step 2. The mass is going to be 40.68 grams. حولنا النسبة إلى grams. And then up here you have the molar masses of the elements, and you know that moles, which is step number 2 to find the moles, is mass over the molar mass. So you divide the mass by the molar mass. Okay, for carbon, for hydrogen as well, mass divided by the molar mass, and for oxygen you divide the mass by the molar mass, and then you get the number of moles. Sorry. Okay, now this is steps 1 and 2. الحين من هذيلا, which one is the smallest number? Is it 3.38, 5.04, or 3.39? Of course it's this one. This is the smallest. Now divide everything, this one divided by itself, this one divided by this one, and this one divided by this one to get the ratios. So this is the mole ratio. Okay, so now for step 3, calculate the simplest by dividing by the smallest value. Mean the smallest value 3.387. So divide moles of C by 3.387 يعطينا 1. Divide the moles of hydrogen by 3.387. So it will give us 1.49 هي تقريبا 3 على 2. And then divide moles of oxygen by 3.387. So it will give you تقريبا 1.001, which is 1. So now if we want to write the formula, how many carbons do we have? 1. So we put 1 down. How many H's do you have? 3/2. How many oxygens do you have? Only 1. Is this correct? No. Remember, we talked about this in the previous video. We can't have a subscript like this. We need to remove the 2. How can we do that? We multiply everything by 2. Okay? So, if we multiply everything by 2, okay, then the new ratio will be 2 to 3 to 2. Okay? شو معنى هالكلام اللي كتبوه هني؟ It's this one. Okay? We have the ratio is 1 to 3 to 2 to 1. So actually, what we need to do, we need to multiply everything by 2. يعني ال C نضربها في 2. أنا كان عندي 1. So نضربها في 2. الثلاث على 2 نضربها في 2. الواحد تبع الأكسجين نضربها في 2. So it will become C2H3O2. Now this is the simplest whole number ratio, and this is our empirical formula. Okay? الكتاب حله يطول شوي بس للتوضيح فقط. Did we finish the question? No. We found the empirical formula. We need to find the molecular formula. So to find the molecular formula, step 1 is to calculate the molar mass of the empirical formula. Molar mass of the empirical formula, it's C2H3O2, right? So directly 2 ضرب, this is the molar mass of C, 12.01 بلس كم اتش عندنا 3 ضرب 1.008 بلس كم او عندنا 2 ضرب 16 and then you will get your answer. So if you do it, if we add these answers, you will get 59.04 gram per mole. So this is the molar mass of the empirical formula. Now that you found the molar mass of the empirical formula, remember what they give us in the beginning of the question. They give us the experimental molar mass. Remember this? Now this is different. This is different from the molar mass of the empirical formula. This is different from this. So what we need to do, we need to divide the experimental molar mass by the molar mass of the empirical formula. So this one was given to us in the question, right? So we need to find n, which is a multiple. We divide the molar mass of succinic acid by the molar mass of the empirical formula اللي حسبناها قبل شوي في الصفحة اللي فاتت, which is this one. So we divide 118.1 given from the question by 59.04, which we calculated. We get 2. So now, to find the molecular formula, we need to multiply the subscripts in the empirical formula by 2. شو معنى هالكلام؟ We need to multiply 2 by the empirical formula, يعني 2 ضرب هاي 2 ضرب هاي and 2 ضرب هاي. Okay? And this is going to be our molecular formula. Now these are the steps that we use to find the molecular formula. Okay? And that's it. This is the whole lesson. This is the last part of the lesson. Okay? There is some practice here. The answers are here for the empirical and molecular formula. You can try it on your own. It's a very simple question. Okay? It's a compound made from nitrogen and oxygen. Everything that you need is here. This is the experimental molar mass. Okay? اللي نستخدمها up here to find n. This is the experimental molar mass. They are asking about the molecular formula. So you can do this on your own and then check your solution because the solution is here. Now this is the end of module 9 lesson 4. So what we learned was the following. In the 3 videos we learned how to calculate the percent composition of a compound. Remember, percent by mass. Okay. We learned how to find the empirical formula from the percent composition, the 4 steps. And we learned how to find the molecular formula from the empirical formula in this video. Okay. If you have any questions, please let me know. I wish you all the best بإذن الله.